Hello everyone, I'm delighted to welcome you, our global audience, to this, the Bridgestone World Solar Challenge Virtual Forum. My name is Chris Selwood and my job today is to try and keep our speakers on track, so wish me luck. Let me start by acknowledging we're presenting from the traditional lands of the Kaurna people of the Adelaide Plains and that we respect their spiritual relationship to country. And while it was immensely disappointing that the disruptions to the international travel scene forced us to cancel the 2021 Bridgestone World Solar Challenge, we were delighted to see teams rise to the challenge set by the virtual activities we have been enjoying this week. But for today, we're focused on a wider audience and celebrating our passion for solar cars by examining where we've come from, where we are now, and how this might provide a signpost for the future. But before we set those scenes, let's hear from our first speaker and remind you that we have designed this to be an interactive forum. Many of you have already submitted questions, and although we could undoubtedly fill the allotted time with those, we are also encouraging questions from the floor. So to submit your questions, you can use the link on your screen. And anything we don't get to during this session, we will endeavour to respond appropriately during the coming days. But now, to kick us off, I'm honoured to welcome Dr. Cathy Foley, who is Australia's Chief Scientist, to introduce the session.
Hello, I'm Cathy Foley, Australia's Chief Scientist. I'd like to begin by acknowledging the lands of the Cammeraygal people, on whose lands I am sitting. I'd also like to acknowledge the lands of the Indigenous people across the Northern Territory and South Australia, where this event normally takes place. The Solar Challenge traverses the lands of 24 different communities. I'm delighted to be able to deliver this message to you today. I'm only sorry that I'm not bringing down the starting flag in Darwin. And I'm sure those of you overseas are disappointed you're not here in Australia to experience our outback and challenge yourselves and your cars over those 3,000 hot, demanding kilometres. However, I can see a silver lining. The Telemetry Challenge is a great initiative. Now, I love data, and I expect the Telemetry Challenge to unlock mountains of fascinating, rich and useful information that can help to improve everyone's understanding of how these vehicles can continue to develop. One of the things I am focused on as Australia's Chief Scientist is improving the way scientific information and research findings are shared. Open access to research and data speeds science and discovery and improves efficiency, accuracy, and collaboration. These are important concepts, and it's great to see that you are able to share real-time performance data. I hope this aspect of the challenge will continue as part of the competition when you return to tyres on the tarmac here in Australia in years to come. I'm a fan of the Bridgestone World Solar Challenge for the way it so wonderfully demonstrates science in action. I know what it's like trying to turn scientific discovery into real-world applications. I spent long days in the lab trying to solve niggly, difficult problems in my superconducting research, and then translating that to a device that worked efficiently in the field, in a commercial application. It's tricky, as you know well, and it takes engineers, designers, technologists, and enthusiasts to turn that basic research into impact. There is so much specialist work that goes into making a car that can race across the outback on solar energy. It's the culmination of breakthroughs in everything from solar panel technology to efficient motors, materials technology, design and manufacturing. I've had a connection with your event in the 1990s when I was a program director, supporting the team developing the in-wheel motor. The CSIRO really cracked the design with a super efficient motor that is now used by many cars. I remember watching the Aurora 101 practicing on the ring road at the West Lindfield National Measurement Laboratory where I worked. It was inspiring to see research being translated into action like that, right outside my office. And then the Aurora won the event in 1999. I was also able to observe the development of flexible solar cells. We used the equipment originally built to print polymer banknotes and found another use for it in the field of solar energy. The technology is now delivering portable solar lighting to disadvantaged areas in India. So it's having real-world impact. We've come such a long way since that first World Solar Challenge. Now, solar is at the heart of our energy future, and we're all in a race to that outcome. I commend the instigators of this event for their vision and those who have worked over so many years to keep the event on the international circuit. I've known John Story for a long time, since I was a postgrad in fact, and it's great to see he's still so closely involved. I congratulate the teams who have done the hard work to prepare. For the students and postgrads among you, you have chosen wisely. This is real experience-based learning. And I understand that you will hear now from the alumni of the Challenge event who are now working at the commercial edge of vehicle technology. What better evidence do you need that there is a great career pathway ahead? The expertise, innovation, and invention you can bring is just what the world is seeking right now. I wish you well.
Thank you, Dr. Foley. We are truly honoured to be recognised at such a senior level, and we truly thank you for your support. I have to say, you may have unknowingly already introduced our next speaker. Professor John Story is one of the few people who has taken part in all 15 editions of this event. Over the last, 34 years or so of engagement, he has embraced the roles of competitor, official, and is now our chief scientist, bringing his own unique perspective to many aspects of the event. John will present some of this perspective and his philosophy on the evolution of the event, and please join me in welcoming Emeritus Professor John Story.
Well, thank you, Chris, and good day, everyone. I'm currently sitting at home in beautiful Yass Valley near Canberra, and I'll start by acknowledging that I live on the land of the Indigenous Ngunnawal people and pay my respects to their elders, past, present, and emerging. Let's go back to the very first Solar Challenge in 1987. In that inaugural event, I was a competitor, like most of you are now, with Team Marsupial. Back then, the rules were very simple, mainly because no one knew how to build a car to drive from Darwin to Adelaide, or even if it were possible. This was an incredible event, and everyone knew that it would be the start of something very big. In 1987, the Stuart Highway wasn't even fully paved. Two teams, including ours, had support helicopters. There was a field of 22 entrants, and it was won by GM's Sunracer at an average speed of 67 kilometres an hour. Things were very different back then. Back in 1987, there was no GPS, Iridium, World Wide Web, Wi-Fi, lithium batteries, and mobile phones barely existed. Technology's changed dramatically since then, and with it, of course, the Bridgestone World Solar Challenge. So let me change gears now and try to summarise the philosophy behind the regulations. In 2009, the scientific faculty was created by Chris Selwood to provide advice on the regulations and other technical aspects of the event. I've been honoured to be a faculty member since its inception. First and foremost, the faculty strives to draft regulations that minimise the risk to participants, spectators, and other road users, and that allow all teams to compete on an equal footing. Our aim is to ensure that there's no incentive to build an unsafe car, ensure that participation is open to the widest possible community, ensure that the rules are unambiguous, transparent, and equitable, to avoid arbitrary and unnecessary rules, and to ensure that the vehicles are fit for purpose. That is, that they're suitable for use on public roads that are occupied by other road users. This means complying with the Australian design rules to the greatest practical extent, and referencing existing UNECE rules. We believe that you know how to design a much better solar car than we do. We therefore want to give you as much freedom as possible in that design. In order to stimulate innovation, the best thing that we can do is to get out of your way. For example, the regulations talk about a solar collector, not a photovoltaic array. In the past, we've seen a steam engine, a Stirling engine, various kinds of tracking concentrators. You can even grow sugarcane on the solar collector and turn it into ethanol fuel if you like. You don't need to use batteries. We simply talk about an energy storage system. In the past, teams have used ultracapacitors, lithium thionyl chloride cells, and compressed air. And one team even did away with the energy storage system altogether. And they finished. Our rules have evolved over the years as better ideas emerge. For example, we've specified the occupant cell and improved the impact protection. We created the concept of a safe state. We now use a defined solar cell area instead of panel area. We use battery weight as a proxy for capacity. We've changed the control stop procedures. And of course, in 2013, we created the cruiser class based on previous cars like Ned and Kelly from 1999 and the Bochum car of 2011. Over the years, some rules have come and gone. For example, there used to be a cutout class, a two-seater class. We used to allow auxiliary solar panels. We even used to allow rear wheel steering and require all cars to have four wheels. So in the moment, Peter Pudney will talk more about the future, but to get back to the philosophy, as you know, our goal is always the same, to stimulate the innovation and development of vehicles that are lightweight, efficient, and powered purely by solar energy. As Nobel Prize winner Dennis Gabor suggested back in 1963, the best way to predict the future is to invent it. You are that future, and it's yours to invent. Thank you.
Thank you very much, John. You brought up quite a swag of interesting points, some of which may even deserve to be revisited when we plan our future events. Thank you very much for your contribution, and we look forward to catching up in person before too long. Now, it's long been recognised that experiential learning and the exercise of participation has opened many doors for alumni of the event. There are many stories, but to gather the common themes, I would like to welcome Andres Sampsons, another long-term supporter of the event, whose experience started as a student when he joined the Michigan Solar Car team in the US. Now a senior engineer at the Ford Motor Company and a PhD candidate himself, and also leader of the Aurora Solar Car team, Andres is here to tell us that not only does he have his dream job, but he has his own unique perspective on the events. Andres, please share with us how you have been influenced by solar cars in general and the Bridgestone World Solar Challenge in particular.
Thanks, Chris. Good morning, everyone from Bayside, Melbourne. Today marks a change to restrictions here in Victoria, and a real sense of optimism is in the air. I look forward to going back on campus with my vehicle design students and can't wait to see you all in Darwin in 2023. Like Professor John Story, my solar car journey also started in 1987. Growing up in the 80s was an awesome experience, as it was a time of significant technological development and cultural change. Personal computers, video game consoles, cable television, and mobile phones all became popular. For me, however, the greatest moment was when I first saw pictures of GM's Sunracer winning the inaugural World Solar Challenge. Imagery of Sunracer's sleek form gliding across a seemingly alien landscape captivated me. What was covering the vast majority of the car's surface? Why were the tires so narrow? How did it travel so quickly in complete silence? Where was this sunburnt country where it drove? I needed to find out. Not only that, I needed to go there and experience it for myself. As a student at the Kalamazoo Area Math and Science Center, I participated in General Motors Sunracer Educational Outreach Program in 1988. This led me to drive the University of Michigan Sunrace 93 winning entry, travel to Australia, and ultimately compete in the 1993 World Solar Challenge against automotive giants such as Honda, Toyota, Nissan, and educational institutions such as Beale, Stanford, and Tokai. Along the way, I found out much about myself. I was quite handy behind the wheel of a car, wanted to work outside as much as possible, and hated sitting in meetings. I took advantage of the opportunity to build and develop a solar electric vehicle, travel widely, and compete in the two most important long-distance solar car events against some of the brightest minds in the world in the spirit of friendly competition. This was truly an adventure of a lifetime for me, a shy kid from Kalamazoo, Michigan. As a direct result of my solar car experience, I secured my dream job as a professional car tester. The lesson that I learned in the 1990s is just as relevant to you today. In a difficult job market, participation in a unique, high-profile design competition, such as the Bridgestone World Solar Challenge, can set you apart from your peers. You have the opportunity to develop and demonstrate your abilities in front of a global audience. The Bridgestone World Solar Challenge is called a challenge for a reason. Equal parts intellectual exercise and physical endeavor, the event, which is often referred to as brain sport, will test your skill, determination, and resilience as few other competitions can. As Chris says, the proposition is simple enough. Build a solar-powered car and drive it across Australia. You, however, may find out that the execution is much more difficult. You and your teammates must project manage, fund, design, engineer, build, test, and field a solar electric vehicle for use on public roads in what may be the world's most dynamic design competition and one of the great adventures of our time. Given the significant technological progress since the first event in 1987, today's solar cars are much more efficient and capable than older vehicles. This has allowed the competition to become even more intense, where top teams can finish in Adelaide within minutes of each other after 3,000 kilometers of driving. I'm excited to see how your team will perform in 2023. In parallel with the competitive aspect of the event, your participation provides a globally visible opportunity to positively influence discussions regarding climate change and demonstrate how both continuous improvement and technological breakthroughs can make the future a better place. The Bridgestone World Solar Challenge can also be great fun, generate wonderful moments to remember, and develop lifelong friendships. I enjoyed my time as a competitor and wish you the best of luck in preparing for the next event. I'll leave you with a final thought, adapted from the event's unofficial theme song, written and performed by scientific faculty member Dr. Rand's son, Toby. It's now time for you to live this moment and embrace fun. Thanks very much.
Thank you, Andris. It certainly continues to be an interesting journey. We have had a question come in that I will put to you now. Some teams, including Aurora, have developed breakthrough technologies to find success in the Bridgestone World Solar Challenge. What is Aurora's secret, if you're allowed to tell us? And what tips can you give teams working towards 23? And if I might add to that, perhaps you could start by saying what is the question referring to in terms of breakthrough technologies that has helped Aurora find success?
Well, I often think that opportunity comes where necessity and capability meet. And as previously stated, Aurora was involved in the co-development of the CSIRO wheel motor. That, along with perhaps the earliest use of lithium batteries in a vehicle and our infamous triangular rolling chassis, have helped Aurora with success in the past. And I think it's this thinking outside the box and utilizing the wide variety of talents in your team that can be productive in the future for developing new and breakthrough technologies that can help you in future events.
Awesome. Thank you very much. Do you have any other tips for aspiring teams for 23?
Whilst funding is important, I think history shows that even the most well-funded teams often encounter problems. I think the key is cleverness, and that can allow teams that may not have the highest level of funding to compete with the much more well-funded teams.
Excellent. Thank you very much for that perspective. And I think, yes, it is absolutely fair to say that the future lays between the ears of our participants. And in one of my corporate talks, I talk about what does it take to find success in the World Solar Challenge, and is it the technology, or is it the money, or is it something else that's a little bit more intangible? And that's exactly where we go with that. Thank you very much, Andres. We look forward to catching up with you in the fullness of time when we're able to travel more and get together. Now, we know that the event is one of extremes on so many levels, and our past certainly holds valuable experience and can be a useful tool to help us shape the future. Everything evolves, but always from our current position. New teams often ask how they can be best prepared to take on this, the ultimate in solar challenges. And I'm delighted to say that we have with us Dr. John Ward, who is our Chief Scrutineer, and he has been invited to share with us his experience and highlight some of the common problems that we see new teams struggle with. And I think some of them may be a little bit surprising. John.
Thanks, Chris. So firstly, I'd just like to welcome you all today to this virtual session, wherever you are around the world. And in my case, I'm on the traditional lands of the Awabakal people. I'd like to pay my respects to the elders past and present. I also extend this acknowledgement to the traditional owners of all the lands that you are on as we live and work today. So, the present. The Bridgestone World Solar Challenge is not only a great adventure, but a huge technical and logistical challenge. But before I get ahead of ourselves, it's worth asking why any of us would want to embark on such a challenge. Fundamentally, this is not a challenge to design a better solar car. And although our stated aim is to stimulate research into and development of sustainable road transport, the essence of this amazing challenge is to envisage a better world and then show the world that we are the ones who can achieve it. Or as our sponsor Bridgestone puts it, to help ensure a healthy environment for current and future generations. But don't just tell us what the world needs to change, show us that you can be that change. So, how do we show the world a glimpse into this future? One way is to think about what special moments we can together create that change mindsets. Some examples of this for me include when solar cars reached the point where there were multiple vehicles that could run at the speed limit, 1,500 kilometres to the south from the South Australian border, all the way through to the finish, although we did fix that. When a cruiser class car was able to drive through Alice at urban speeds with 4 people on board and was energy positive. The multiple times when teams suffered an immense setback and the solar car community came together to overcome the challenge and got them back on the road. And finally, when in the last event, we hit the Cooper Pedy electricity system with simultaneous EV charging demand and bumped the grid frequency, showing how EVs not just can, but need to contribute to the operation of our wider energy infrastructure. Our cruiser class vehicles demonstrate more practical solar EVs, and with over 1,000 kilometres range and smart grid interactivity, our teams are challenged to solve additional crucial pieces of the sustainable road transport puzzle. These examples are meaningful to me, so ask yourself, what glimpses into the future can you provide? Despite our ambition, we cannot achieve any of this without preparation. The importance of being properly prepared cannot be underestimated. So how can you prepare for the unknown? Research and homework are prerequisites for any real adventure. And no, it's not easy. We pride ourselves on being a solar community. We're able to support each other. However, it is your own responsibility to ensure that you have made arrangements appropriate for your circumstances and have all the equipment you need to complete the challenge. This starts with your team being in Darwin, all of them. You'll have had 2 years to plan, so please don't expect that team members can arrive late. It's not only disruptive, but can seriously impact fatigue management. We want you to be here, and we will help you with this. In addition to the regulations, we published 2 important documents for you, the Team Manager's Guide and the Freight Manual. Each of these contain important information to help you prepare for the adventure. So please don't wait till the Team Managers meeting to find out what's needed. We ask you for technical documentation on your solar car, and if this is submitted on time, we can make suggestions to help you. Late documentation and last-minute changes leave you open to losing this aspect of our support. Remember too that we operate on public roads. We anticipate that in 2023, your engineering certificate will come under much greater scrutiny by the road transport authorities. So make sure it contains sufficient detail and is signed off by a suitably qualified engineer. Anyway, that's enough on preparation. Let's talk scrutineering. The purpose of scrutineering is to confirm that the vehicle presented is the vehicle described in your documentation, that the regulations and design requirements have been met, and finally, that the minimum safety standards have all been achieved. For us, an important concept here is that it's not the aim of the scrutiny is to find fault. The onus of compliance is absolutely with you, and as such, you may be asked to explain your design choices. We want you to be successful, but like every other time, you'll want the competition to be fair. So if a problem arises, yes, we may look at non-compliance penalties and issue those. We'll also provide an opportunity for you to correct the problem and represent. Once your solar EV has successfully completed static scrutineering, we then move on to dynamic scrutineering. This includes safety exercises with the on-road transport inspectors and a timed lap to determine starting positions. All being well, your team will be issued with a green ready to start sticker, and then the real fun begins. The road trip itself is not for the faint-hearted. It is extreme, and that's why you want to come, right? You'll follow the only major north-south highway crossing of this continent, the Stuart Highway. As you cross through several distinct climatic zones, one at a time, you'll have to be self-sufficient, and there are very few facilities out there in the desert. This is one of the most remotely populated areas of the planet, so wherever you get to at 5 p.m, that's where you'll stay the night. As we said, it's a great adventure, so remember, the secret here is to arrive in Darwin with plenty of time to enjoy the sights, shop for your on-road needs, and get prepared. In terms of progress, we suggest that achieving 500 kilometres per day is not unreasonable. This is just simple math, 3,000 kilometres over 6 days for the event. So the closing time of the control stops is calculated to reflect this minimum progress and show that you're keeping up. As in previous years, event officials and event safety cars will oversee your progress. This has worked well in the past, so we do not anticipate any major changes to the way we do things on the road. So, be prepared, inspire and amaze us, not just with your ideas, but your ability to build and demonstrate what our solar car community can do together. And for those of you that take on this challenge, in the testing grounds of the harsh extremes of the Australian outback, and succeed, you should be immensely proud. We look forward to our borders reopening and welcoming you to Australia. See you in 2023.
Brilliant. Thank you very much, John. Has been a question come through for you. And if I paraphrase it, you mentioned the need for a certifying engineer. Can you help us understand who qualifies for that role?
Thanks, Chris. So in many countries of the world, this would be what we'd call a PE or a professional engineer. So the definition of a professional engineer varies around the world, and this is a truly international event. So what we're looking for is requiring a certifying engineer that's someone who is recognised in the team's country of origin as being able to take legal responsibility for approving and certifying the design and construction of the solar car as being suitable for driving on public roads.
Thank you very much. And I think that's what I've heard referred to elsewhere as being fit for purpose. The key to all of this is our public road network and our permission to play with our individually constructed vehicles, our homemade cars on public roads, and not everywhere in the world can do that. So it's a precious asset. So everybody, we appreciate everybody helping us to keep the authorities on side by not being too extreme, shall we say. Thank you very much, John. We're lucky to have you on our team. Now, let's move on to one of our favourite spaces. For what would a great adventure be without some unknown territory? I'm delighted now to introduce Dr. Peter Pudney, faculty member and chair of the International Regulations Committee. Peter and I have been playing with solar cars for a very long time, and I'm delighted to say he is here with me in the studio here on Kaurna country. And I can think of no one better to offer some predictions of where our regulations might go, and then to lead a discussion on our regulatory philosophy. And of course, it's not too late to put questions on that link and have access to this distinguished panel. Peter.
G'day, Chris. Thanks. So John Story's already given a great summary of how the event has evolved since 1987. And so in this session, we're going to focus on the future of the event and answer some of your questions about future regulations. So firstly, the event is the Bridgestone World Solar Challenge with the emphasis on solar. So first and foremost, it's about doing something amazing with solar power. So transporting people across a continent at highway speeds powered by only 4 or 5 square metres of a shadow is pretty amazing. And the event is also a challenge. It's not easy. Organising an outback road trip can be a bit of a challenge, and it's more challenging if you have to build your own car to do it in. And then having that car powered by sunlight makes it a real challenge. And then, of course, you have to find someone to pay for it all. So as John mentioned, the regulations are designed to enable fair comparison between cars and teams so that we can declare a winner in each of the classes. Each team is allowed the same solar collector area, the same amount of energy storage, and the same driving times on the road, and they must carry the same size and weight of occupants. Now, determining the winner of the Challenger class is pretty straightforward. It's whoever reaches Adelaide first. The Cruiser class is a bit more difficult. So, Cruiser class was established to answer 2 questions. The first question, which we're often asked at the end of events, was, will these things ever be practical? And the second question was, how can teams avoid being beaten by Nuna and occasionally Tokai? So, comparing the performance of Cruiser cars is always difficult. We value the diversity of teams, so we like to see the 2-seater cars and the 4-seater cars, the family cars, and maybe even in the future mobile homes and so on. So we want teams to find their own balance between efficiency and practicality, which often annoys the teams. They want sort of guidance on what should we actually be building, but really it's up to you to do your own research into what you think people will find attractive and then justify to us your decision to build a particular style of car. Ultimately, it would be nice if cruisers didn't have to recharge from the grid. So in the last event, we allowed cruisers to recharge twice as they came down from Darwin to Adelaide. So that meant they had to drive 1,200 kilometres without recharging, which in comparison to other EVs that you might buy at the moment, that's a pretty amazing feat. But they're still using energy from the grid. It would be nice if they didn't have to do that. But at the moment, the extra size and drag and mass and the requirement to cross a continent in just 6 days means that there's still a bit of a challenge there. So the regulations are set by the scientific faculty that Chris set up a few years ago. And every couple of events, we allow ourselves to make significant changes to the regulations in order to keep the event challenging. And in the alternate years where we don't make the major changes, we just make minor changes, and they're usually just to clarify the intent of the regulations and close any loopholes that some of the teams may have discovered. And we also respond to changes in technology. And we also talk to other events around the globe, and we are striving for harmonisation of technical regulations across all of these events. So now let's get to your questions, and let me introduce the panel who are some of the members of our scientific faculty. So, Chris, you've already met all of these people, except down in the bottom right-hand corner, we've got Dave Snowden.
Dr. Cruz.
Dr. Cruz.
Yeah.
So the questions, so some of these questions have come in prior to this event, and we'll also be taking questions that you can type in as we speak. So one of the first questions, and this is one that we get from several people, is what planet is Pat from? So PVC Pat is a simple mannequin that we devised for the 2021 event, used to define the minimum occupant space. So prior to 2021, we noticed that a lot of teams were really squeezing their drivers into the cars in a way that was, that they were having to drive down the road with their shoulders sideways and so on. So it's not good for the comfort of the driver and fatigue management. And in order to once again sort of make the comparison fair between cars, it's fair that each car has the same amount of space for the driver and other occupants. So PVC Pat is a simple mannequin. You can build one yourselves. There's instructions on the website, made out of rainwater pipe.
Metric or imperial?
Yeah, and 90 millimetres or 3.5 inches or something.
Something the Americans use.
Yeah. People have questioned the dimensions. Pat looks awfully tall, but Pat dimensions are 95th percentile dimensions for international males and females. And I got the data from the DINED Anthropometric database from the Applied Ergonomics and Design section of the Human-Centered Design Department of the Technical University of Delft, Faculty of Industrial and Design Engineering.
Does that mean it's Nuna's fault?
It's Nuna's fault that we have such a huge... So even though they say that it's for international males and females, I suspect there may have been quite a few Dutch people in amongst their 95th percentile set of people that they were sampling. Okay, the next question is about the lithium iron phosphate cells. So we allow 40 kilograms of those in the regulations. A few teams have noticed that you can get a lot of energy into 40 kilograms of lithium iron phosphate compared to the 20 kilograms of lithium. John, why did we allow that to happen? John Ward.
Thanks, Peter. So just as a starting point, when we released the 21 regulations, best available lithium iron phosphate cells are just over the specific energy of lithium ion and lithium polymer. And those are the ones that we allow 20 kilograms. So we were happy with that slight energy advantage of the chemistry because of the trade-offs on other aspects of their performance. And that included that we found teams found this an easier chemistry to handle safely. So when choosing a cell, it's really important that, as with all engineering design decisions, other factors are also really important into what you do. So what's the round trip efficiency? What's the internal resistance? Can your vehicle even accommodate the additional mass? So you also need to be aware that sometimes we find multiple conflicting versions of data sets, including early tentative specifications and a few others that are floating on the internet. So just also be aware that if it sounds too good to be true, it may well be. So since 2020, certainly the specific energy of lithium iron phosphate's gone up faster than some other cells. This is great. We'd love technology to advance. So we may end up reducing the allowable mass of lithium iron phosphate in 2023, but we're still likely to favour the chemistry.
Okay, thanks, John. And so you might have noticed also in the past few years, we used to just specify the weight of batteries that was allowed, and we would have teams arguing with us about how much their cells actually weighed. They'd send us videos of them measuring every cell, and we really don't want to see that. And so for standard cells, such as the 18650s, we now specify just the number of cells that you're allowed, and that makes it easier for everyone. Okay, we've had a question about perovskite and silicon tandem cells, and will we be allowing these new multi-junction cells in 2023? So this was a question that came up in 2021. Several teams, and indeed a manufacturer of these tandem perovskite silicon cells, asked us about whether or not we would allow these cells in 2021. And the short answer is yes. The environmental toxicity of the cells is low compared to gallium arsenide, and they're looking like a really promising technology. The difficulty was when we asked even the manufacturer, what the efficiency of these cells was, they weren't really able to tell us, because they'd made some very small cells that they had tested for inclusion in the world record efficiency list, and that had an efficiency of, I think, 29%. But their production cells were not quite going to be at that level. So we are still waiting to see what the actual production efficiency is going to be for those cells, but it's quite likely that we will see those cells in 2023, and we certainly will be allowing them.
Peter, how does the event determine the metrics and efficiency of a cell?
Yeah, so generally we look at the world record efficiencies of different cell chemistries, and these are reported in the solar cell efficiency tables that are published twice a year. I can't remember what the name of the journal is, but if you look up solar cell efficiency tables by Martin Green and colleagues, then you can get all that information. And normally we would look at the world record efficiency of the cells and say, all right, based on that, that determines the area of panels, the area of cells that you're allowed on your car. We try and give everybody the same solar collector area, so 4 square meters for Challenger cars and 5 square meters for cruiser cars. In the case of the perovskite silicon cells, the world record cell was only a very small, sort of 1 centimeter square cell, and we know that the actual production cells are not going to be quite as good as the world record cell. So we will allow for that, but we are still waiting for detailed specifications of the efficiency of these production cells before we can tell you exactly how much we're going to allow. So as soon as that information comes through, we will give you a ruling on what area you're allowed. As John Story mentioned earlier, it's not just about PV cells. So any other technology that you may have for converting sunlight into energy that you can use to propel the car, we will look at that. And essentially our requirement is that we give you 4 square meters of area to collect sunlight from, and you can do whatever you like with that.
And is that what we as human beings each have these days?
Hans Tholstrup apparently did a calculation right at the beginning of the event as to what each person's entitlement of solar was, and I think it was 8 square meters at the time.
It was 8 then,
yeah.
And for our 30th anniversary we crunched them. It was one of those occasions where we did actually sit down and had some blue sky thinking, and spoke to some recognised experts on world population, that it had changed over the 30 years from 8 square metres to 4 square metres.
We also found that cars with 8 square metres of solar panel were able to go very fast.
And impossibly big.
And were large, yeah. It's interesting though, 5 square metres for the cruiser class is probably a bit small for energy collection. The cruisers aren't able to get all the way from Darwin to Adelaide without recharging from the grid. But our limit there is we also have to be able to fit these cars into shipping containers to get them to Australia. So there's a trade-off there. Okay, we have a question from Anthony from Tasmania, who asks whether we would allow other forms of non-polluting motive power. And he's specifically asking what appears to be about compressed air. And as John Story mentioned, we have had compressed air in the past. So a fundamental requirement of the Bridgestone World Solar Challenge is that the car is powered by 4 or 5 square metres of sunlight. Now, this restriction on the solar collection area means that if you want to collect enough energy to drive from Darwin to Adelaide, you have to be collecting energy while you are driving. Though that's not necessarily true. In 1996, there was Team New England's Pumpkin Seed. It was a very small car that raced along the highway at 100 kilometres an hour for 100 kilometres or so, and then would stop and roll out a solar panel and recharge. But apart from them, everybody else tends to collect the solar energy as they're going. So there's no restriction on how you can store that energy, but the amount of energy that we allow you to store will be limited to about 5 kilowatt hours, and that's about 10% of the energy required to complete the 3,020 kilometre trip. In cruiser class...
No reason, Peter, why you can't use a compressed air motor if you're going to store your energy as compressed air. Get rid of all this electronic stuff.
It's certainly worth thinking about.
Invent something new, that's the point, isn't it?
Yeah. When you are considering new ways of storing your non-polluting energy, it is important to consider the energy and the emissions associated with producing that stored energy from solar as well. So I guess there's a lesson there that we need to think about when we're thinking about things like hydrogen. In cruiser class, there is no limit on the amount of storage you can have with you, and we tend to see cars with fairly large batteries in order to make the 1,200 kilometres between Tennant Creek and Coober Pedy.
The trade-off, of course, is the mass of the battery that you choose. So.
And we penalise teams in the scoring for the amount of external energy that they use. So if you can build a cruiser car that doesn't require a large battery, then you're going to be better off.
Yeah, as Chris said, though, as that mass goes up, we've had cars that have not actually been able to have an occupant in all of their seats because the mass of the car just got too high. So absolutely that engineering trade-off.
Real world stuff. Is it too early, Peter, for me to talk about what we've done in the past with alternative technologies demonstrating their capability?
Away you go.
Certainly through the early part of this century, we had a number of events where we invited new technology vehicles to demonstrate their capability, and that started to become quite popular. But there are some parameters around that, and in general terms, consideration would be given to something that would demonstrate the practical outcomes of technology that was developed for the World Solar Challenge, and vehicles that have been designed, modified or equipped to reduce their environmental profile. But they need to be approved by the Road Transport Authority to operate on the public highway, and are capable of a minimum progress of 500 kilometres a day, and meet the operational and safety requirements of the event to travel from Darwin to Adelaide. I know I've had people in the past say, I want to display this thing in Victoria Square at the finish line because it's going to save the world. But if it's not a practical proposition, if it can't drive from Darwin to Adelaide, it's hardly going to make that contribution, certainly not in the short term. I love mad inventors. I've been a bit of a mad inventor myself over the years. But we do have to recognise where we are, that this is an appendage to our solar car event, and these things have been there as, shall we say, guests, not in any competition, just demonstrating capability. And it's not completely out of the question that we might look at that again in the future and have some of those things. So keep the inquiries coming, certainly, but don't expect that we will automatically give a positive answer.
We have a question that's come in online. do you think the weight of the solar cars, given the weight of the lightest solar car in Morocco, I don't know what the weight of the lightest solar car in Morocco was, but I imagine it's probably
129 kilos, I
okay.
believe.
Yeah. So, do we think the weight is going to increase the chance of, or this low weight is going to increase the chance of solar cars being blown off the road by Australian road trains in huge crosswinds? And I might go to John's story on that, because John's been thinking a lot about weight and suspension and so on, given that in the last event...
Stability?
Stability. We had a few cars come off the road in high crosswinds.
Yeah, look, it's a really interesting question, Peter. And as you say, I've written a document which is on the Bridgestone World Solar Challenge website, which just goes into some of the considerations that people might like to think about if they're going to design a car that's relatively easy to drive and is stable and won't be blown off the road. And it's complicated. One thing I can say is that we've looked in great detail at what happened in the 2019 event, and there's no correlation between the weight of the vehicle and its stability. Some of the heaviest vehicles, or heavier vehicles, had trouble in the winds. Some of the lighter vehicles had no trouble whatsoever. And so it's not just a matter of weight, it's how you distribute that weight and how the interaction between the aerodynamics of the car, the suspension of the car, and again, that weight distribution. So great question, but one of the things that we did consider is having a minimum weight for cars, and that again would be, I think, an arbitrary rule and one that wouldn't necessarily lead to more stable cars.
Thanks, John. So Anthony, who asked about the alternative energy storage systems, also asked about what innovations are required in the field of EV connectivity to the grid. And we did this experiment that John talked about in Tennant Creek and Alice Springs Coober Pedy and Tennant Creek last time. John Ward, tell us about connecting vehicles to the grid.
Yeah, the experiment we ran last event was fascinating. Tennant Creek, we had cars that couldn't charge when they thought they could charge, simply because the temperatures we experience in the outback are a lot higher than people had realised. Coober Pedy, we saw our cars bump the frequency of the grid as they all came on, and that was an experiment that, if we'd have run on the wholesale Australian energy system, the NEM, we might have needed 100,000 cars to simultaneously participate in an experiment. But for Coober Pedy, we could actually run that experiment with our solar car fleet. So that was spectacular. But to Anthony's question, the majority of the production EVs currently simply demand and accept the charge that they want. And that's really just, let's get you back on the road quickly. But as we move to a more renewables-based electricity grid, energy storage is really helpful in managing the difference between that energy as it's generated and used. So storage is going to be a really important factor. And in the future, this immense storage of electric vehicles could be a really good help in this. So some of the things to think about there would be, how do we shape the charge profile of the cars to match renewable generation? Just how fast you can do that. Is this a minutes thing, a seconds thing, a milliseconds thing, a microseconds thing? Yeah, we really want to manage this on an instantaneous basis. How do you coordinate between multiple cars and other things in your energy system? Charging's really just that first step. Full grid interactivity means also supplying energy to the grid or even directly to other vehicles. Another aspect here would be that electronics of particularly DC fast chargers are really similar to what you use for managing power quality. So we can use those electric vehicle chargers rather than buying these things separately. And for the power engineers out there, ancillary services, inertia, reactive power, harmonics, phase balance, all of those sorts of things are things that, managed well, our electric vehicles can contribute to cheaper, more reliable grid operation, which is just different to other types of loads that we might be putting on. So we're really keen for our teams to be thinking about some of these additional factors.
Thanks, John. So we had a question from Alan asking about our opinion on the future of motors and transmissions and sort of the various ways that you might connect a motor to the wheels of the car. I might get John Story to tell us what do you think the future is for improving the efficiency of motors and drivetrains?
Well, I guess the short answer is I don't know, but I can assure you that all of us on the faculty are looking forward as much as Alan is to finding out what happens, what you guys out there can develop. In the early days, there was extraordinary complication in the transmission systems. Cars used bicycle chains, they used gearboxes, multiple speeds, and so on. And then along came the wheel motors, one of which, as we've heard, was developed at CSIRO with Paul Guan, who's now currently one of our faculty members, contributing to that development. What we're seeing now with these wheel motors is peak efficiencies of over 98%. The controllers are more than 98% efficient. And of course, there's no transmission loss. So there's not much to be gained in the future in these areas. What personally I think is that we're going to see the effort going into making broader efficiency curves on these components, lighter weight, especially for the wheel motors, which contribute to the unsprung mass of the car, and hopefully in the cost as well. So let's see what you've got. And by the way, the regulations don't require you to use the wheels to propel you. You can always use a propeller.
Thanks for that wise advice, John. So we have another question come in online. Maybe Chris can take this one. Why aren't cars allowed to drive south of Port Augusta on day 7 of the event?
Oh, well, that was a recommendation of South Australian Police based on the fact that if they've taken 6 days to get to Port Augusta, then their average speed is pretty low anyway. It's a great achievement to have crossed the continent because you go from ocean to ocean. When you arrive at Port Augusta, you're back on the coast on the southern side of the country, so that is a great achievement. But that road from Port Augusta to Adelaide, yes, there's a lot of divided highway in there, but there's also a lot of that road that's not. And there's a lot more traffic than there was 30 years ago. And we've seen, the police particularly, have seen a lot of very frustrated normal traffic drivers driving dangerously to get past solar car convoys. Much as we talk about not convoying, it happens, cars bunch up, and the safety cars have to be continually scuttling up and down trying to break up convoys. So all of that behaviour leads the police to advise that if it's taken 6 days to cross the continent, that last 300 k's, you probably should be on your trailer and get down in time to enjoy the celebrations.
Thanks, Chris. I guess while we're talking about support vehicles and the sort of large teams that come across for the event, so Schroeder's asked a question about support vehicles, and what would solar cars be like without them, and what if the support vehicles were solar powered?
Brilliant question.
Dave Snowden, this is one for you, I think.
Yeah, right. I mean, if we had support vehicles or the sort of vehicles that people wanted to drive in already, we might have less of a competition. We might not have solar cars, but today's EVs, they take about 45 days. They take an awfully long time to drive from Darwin to Adelaide if they were just charged by the area on top of their roofs. So this is one of the reasons that we have a World Solar Challenge event. The alternative would be that, as far as using electric vehicles, but as far as we're aware, no team has used electric vehicles for the event. People certainly drive from Darwin to Adelaide using the various charging points that are along the way, and we'd absolutely love to see teams rise to that particular challenge. The individually constructed cars and the experimental nature of those cars means we have to have support cars, but it'd be great to see solar cars that are reliable and self-sufficient enough that they only need an escort. They don't need a huge support crew. Maybe the cruiser class cars could start to escort the challenges or something like that. We've made some steps towards banning towards all of this by banning charging stands and updating the control stop procedures and things like that. But there's a fair way to go. Maybe we could consider some measure of ecological impact for the teams. Obviously that's quite a difficult thing to quantify and work through. But overall, we're very aware of the sort of environmental impact of the event and the fact that we'd like to reduce it, and any steps we can take towards using the results of the 30 years worth of innovation in the World Solar Challenge to support the World Challenge, Solar Challenge, as in we'd love to be able to have electric vehicles as support cars and demonstrate that this is a realistic proposition today. Would be notwithstanding all of the issues that John Ward was just talking about in terms of the amount of electricity and the impact on the local grids when thousands of or hundreds of very large batteries simultaneously plug in when the teams arrive in town. So we have to take into account those practical considerations. But overall, we're very aware of it. We'd love to work towards it. We'd love to see teams try to rise to that challenge and work out how to get across the country on renewables alone.
And we've certainly talked long and hard and put a lot of effort into thinking about how we might come up with an environmental profile award in the event. It's as Dave says, it's not an easy proposition to fairly and consistently measure those things, but it's not impossible. It's a question of resources that perhaps we aspire to, but watch this space, we might get there.
We've just had a fabulous question come through. It reads, in my opinion, the cruiser class is much less exciting to follow versus the challenge class, where you can just see how the competition unfolds by looking at a map. Can we make the cruisers similarly exciting to follow during the trip down? Well, this is something that we're well aware of, and over the last couple of days, we've been trying to look at ways that we can use data from the teams to support better information about how the teams are going. So we didn't actually have any cruisers in the telemetry challenge, but what we did show was that we can monitor the energy use of cars as they're driving from Darwin to Adelaide, or in this case, the teams were driving in different parts of the world. But we can ask the teams to send us some energy data that tells us how much solar energy have they collected, how much energy have they taken from their storage system. And using that, we can get a real sense of how the efficiency of the car is going, and we can do that in real time. And over the last, over the 2 days of the telemetry challenge, we saw Tokai over the 2 days. They started off travelling at around about 95 kilometres an hour, and we watched their energy efficiency improve as they started to slow down, because they sort of misjudged how much solar they were going to get. They slowed down to eventually down to about 85 or 80 kilometres an hour, and we could see their energy efficiency changing as they were driving. And there was a lot of interesting work happening by data analysts who were analysing the data in real time. And we think by doing some of that with the cruiser class, we can make that a bit more engaging. Okay, yes. Don has asked a question about, can we reduce the cost of participation by for entry-level teams by allowing them to start in Alice Springs? So unfortunately, the cost of participating is high, as well as designing, building and testing a car capable of completing the event You also need to assemble a team and get your team to Darwin, stay in Darwin for at least scrutineering week, but probably week or more before that. You then need to travel down to Adelaide and look after yourself as you go down. You've got to do all your catering and sleeping arrangements and all that sort of stuff. And then you've got to get your team home again. So it's an expensive exercise. Not sure that starting in Alice Springs would reduce the cost by much. And we tried it with the Solar Cycle Challenge a few years ago, where we had separate events. Chris, I can see you're itching to jump in here. Tell us about the Solar Cycle
Not
Challenge.
really, not really. But we recognised this quite a few years ago now, when we started the solar cycles in Alice Springs. It was a good idea at the time to start in Darwin on the Sunday and start in Alice on the Monday, and everybody arrives together in Adelaide. What could possibly go wrong with that? But what we effectively had was two distinct simultaneous events, and the resources needed to support that was stretched us all, moving officials and scrutineers from Darwin to Alice to see those other guys off, because having some consistency, we felt that it was important to have some consistency, so that we had clerks of course and things like that aware of everything that was going on. But effectively it was two separate events running simultaneously. And I am absolutely aware that entry-level events is our future, but there are an increasing number of local events happening around the world, particularly born out of this COVID-constrained situation, where we have events on tracks or on local areas where entry-level teams can get out, exercise themselves and catch the solar car bug, and aspire to work hard, not just on their car, but on their commercial operations and their sponsorship to get the resources to come to the Bridgestone World Solar Challenge, because that's where we would ultimately love to see them. And to those that say it's too hard, look, the group of people here and the other faculty members who aren't work hard to try and keep us ahead of the game and challenge the status quo. And if nobody finished, we would say it was too hard. But we're still around 20% of teams finishing, which shows that it can be done. It can be done successfully, it can be done safely, and that those that finish are a great incentive for others to build a better car and work in a better headspace, some of them.
Thanks, Chris. So I think we've got time for one last question before we wrap up. But so we have another question that's come in. Could the practicality judging for cruiser cars be done in Darwin instead of Adelaide? I'll let Chris answer that one, but the second part of the question is, then teams know where they sit in their scores, and it might help with their strategy during the on-road event. I think I'm going to answer that second bit. Your strategy during the on-road event is really to do as best you can during the on-road event, and it's independent of your score in the practicality. But Chris?
Well, a big part of the practicality of a vehicle, can it do what it's built to do? And it's built to drive from Darwin to Adelaide. So if it can't drive from Darwin to Adelaide, okay, it's an interesting exercise to say, well, the doors are a nice size and you can get a bicycle in the back. But that's why we decided that the practicality should be shown once the car had proven its capability of driving from Darwin to Adelaide.
Thanks, Chris. We might have time for Dave's question about standardising the cars. We've only got a minute or so left, but
Homologation.
John Story, should we just put restrictions on cars like they do in NASCAR?
Yeah, look, I think that's a really important question, because it goes right to the philosophy of the Bridgestone World Solar Challenge. And for us, I think it would be anathema to specify anything that didn't need to be specified. So we specify the safety things like the helmets, the tyres and so forth. They have to meet particular standards. But we're trying to stimulate innovation. And so saying that you have to use a solar panel made by Wombat Technologies Proprietary Limited would stifle that innovation, would kill it stone dead. I can see the point of the question, which is to try and reduce the cost. And in other motorsport like Formula Ford and Formula V, there are restrictions on what you can and cannot use. Similarly, in yachting, the various one-class events. But I think as far as...
No Uching.
No Uching, no. As far as this event's concerned, we're about innovation, and we want to remove rules, not add to them.
Okay, thank you very much, John. And look, thanks to everyone for your questions.
Can I just add to that, really quick, because I know that the control room is telling us that we're running out of time. But on that question of standardisation of parts, and Wombat Technologies make very good widgets, I have to say, but they're only available in Australia. And we're an international event. We have teams from all around the world, and what people can buy easily down the road in Michigan are very difficult to get hold of in Iran. And we've seen that so many times, the cost of things, and I know that the American event has played with the stock class, which is all about stuff that's off the shelf in various places, and that's worked reasonably well. But in the wider international context, it hasn't worked for us at all, which is why we have tended to avoid that. And that's without getting into, do I get stuff that's on the front of the shelf in the shop, or do I get it specially polished for me out the back and then supplied as a standard part? We won't go there in that. But they're the difficulties we face. And as an international event, it's a whole nother level of difficulty that everybody can get those same parts.
Okay, thanks, Chris. And look, thanks everyone for your questions. If we didn't get round to answering your questions, then we'll follow up in the next couple of days. And if you have any other questions or suggestions, then certainly contact us using all the standard links. So thank you very much.
Thank you, Peter, and thank you, faculty. As Peter says, keep those questions coming and we can compile an FAQ for the coming event. The toughest job of all that these guys have is writing regulations around stuff that has yet to be invented, which is why we try and stick to our philosophical concept. I'm excited now to bring a different perspective with our next speaker, Alexandra Bulkov. As a student, Alexandra was a member of the SunSwift team in Sydney here in Australia, and her passion for electric cars led to an engineering career with Tesla. Alexandra has been invited to give her own thoughts on the advantages that Bridgestone World Solar Challenge participation can give to a career in industry. Alexandra.
Thank you, Chris. I'd like to begin by acknowledging the Jurganj people of the Yuin Nation, the traditional custodians of the land from which I'm speaking to you today. So, as Chris mentioned, I last competed in the Bridgestone World Solar Challenge in 2011, which is a full decade ago. On the one hand, I kind of can't believe it's been that long, because being a solar car racer to this day feels like a really big part of my identity. But on the other hand, 10 years is a very short time when I consider just how much has happened in the world of electric vehicles and renewable energy. In 2011, there were less than 60,000 EVs sold worldwide. For those of you living in Adelaide, you were probably more likely to see a solar car driving past you than a commercial electric car. This year, worldwide electric vehicle sales are set to top 6 million. And over the same time, solar energy generation has grown more than tenfold. So I think it's a really exciting time to be an engineer. We are at the beginning of a huge clean energy revolution, and the technology at the heart of solar car racing is more relevant than ever. When I was competing in the World Solar Challenge, I think I was too busy just living the adventure to fully recognize the skills that I was getting through it. But now I can look back at a few years of working at Tesla, and I can really appreciate the things that solar car gave me. So I want to share a couple of those with you. Firstly, the World Solar Challenge gives you the chance to work on a real complex engineering system. And the thing that makes this very different from most of your engineering classes is that what you are building has to work. The pressure is real, because in order to race, you need a working solar car. So this means that in order to get to the starting line in Darwin, you will go through all of the ups and downs of the full engineering design process. You'll have to design, build, test, make mistakes, and then fix your own mistakes and repeat the process until you succeed. Along the way, you'll learn some things that really can't be taught, like the importance of testing early and testing often, and the fact that reliability rather than performance can sometimes be the key to success. And you'll learn some of these lessons the hard way, maybe on the side of the road of the Stuart Highway, but you will get to know the thrill of building something that works, and you'll get the confidence that you can do it again when you start your engineering career. Secondly, the World Solar Challenge is so much more than just designing a car. It's a whole cross-functional team mission. So no matter what your role in the team, you will get exposed to every aspect of the program, from the core engineering design to building the car, project management, fundraising, marketing, and logistics, without which the race couldn't happen. I joined solar car racing as an electrical engineer, but learned all kinds of things I never expected, from how to build carbon fiber composite parts to the preparation that's involved in feeding 20 people for a 3-week journey through the desert. And being able to appreciate everything that's involved and to communicate across different disciplines will make you better at navigating future projects. And lastly, for me, the most important advantage of being involved in the World Solar Challenge was the people I met and the friendships I formed. They say that the person you become is a reflection of who you spend your time with. And let's be honest, solar car racing involves spending a lot of time, a lot of late nights, and a lot of weekends with your team. Fortunately, I think the World Solar Challenge attracts some of the most interesting, fun, and relentlessly motivated people that I've ever met. Being part of this group encouraged me to solve hard problems, how to learn how to trust my own engineering judgment, and how to trust my team. And I think the social aspect of the World Solar Challenge is an incredibly important one that we should all celebrate. The friends that I made through solar car racing are still some of my closest friends today, and many of them are my colleagues at Tesla. So we're still the same motivated group of people, just a decade older, and are now solving some of the world's toughest clean energy challenges. So to all of the current and future World Solar Challenge participants, I hope you really enjoy this incredible adventure and get excited about the opportunities ahead. The confidence and the skills that you are building through solar car racing will set you up to have an interesting and impactful career. And if you're passionate about building a zero emissions future, I really encourage you to check out the internships and full-time engineering jobs on Tesla's career site. We are actively hiring across all of our technical teams, especially in the United States, and we would love to hear from candidates like you. So thank you.
Brilliant. Thank you very much, Alexandra. There's many points there worth pondering, and a great call to action for solar car alumni to get a career in engineering. Which leads us to a question that has come up. And you talked about the perspective of a decade older, and I see that as a space where experience develops wisdom. So the question is that common knowledge says that engineering remains predominantly a male-dominated field. What would be your message to young women hoping to make engineering their profession?
I think my main message is that you should go for it. If you are passionate about building things and solving technical problems, then engineering can be an incredibly rewarding career. And I don't want women to miss out on this. It can be challenging to be one of a few women in the room, and it is important to recognize this, but don't let it deter you. If you focus on mastering your craft and working on problems that are really meaningful to you, I think this will build your confidence. And my other piece of advice is to seek out a mentor. I think this has helped me immensely in my career. And if you reach out to a female engineer that inspires you, this can build a really strong relationship. It can be really helpful to helping you navigate the early years of your career and give you a sounding board for both technical and non-technical advice. And I think a lot of studies now show just how impactful that can be.
Well, I think you better look out for your inbox start bulging. It's certainly an inspiration hearing from you, Alexandra, and the world is certainly changing. Thank you very much for your contribution.
Thank you, Chris.
Well, solar cars run on sunshine, but as I often say, the event runs on dollars, and our naming rights partner, Bridgestone Corporation, is really passionate about this event, which is fantastic. And as always, we are so grateful for their support. And I'm therefore delighted to welcome the Managing Director of Bridgestone Australia and New Zealand, Stephen Roach, who's provided a message for everybody here today. Stephen.
Hi, my name's Stephen Roach, Managing Director at Bridgestone Australia and New Zealand. On behalf of Bridgestone Corporation, thank you for taking part in the Bridgestone World Solar Challenge's 2021 virtual program. Like you, I'd much rather be in Darwin right now for the actual event, but we're glad that we were able to facilitate this forum and celebrate the spirit of the Bridgestone World Solar Challenge. As a company, we place great significance on the global partnership because it aligns with our priorities of people, mobility and the environment in what we refer to as our way to serve. The Bridgestone World Solar Challenge supports the next generation of engineers and designers who will ultimately advance the development of smart and sustainable mobility. That is why Bridgestone is so passionate about this event and has a long-term commitment to the World Solar Challenge. Again, thank you for taking part in the virtual forum. With your ideas and creativity, together we can continue to develop a more sustainable future. We hope to see you in Australia for the 2023 Bridgestone World Solar Challenge. Thank you.
Thank you very much, Stephen, and thank you all for your inspiring words. I think it's fair to say that all of today's speakers have given us a great deal to think about, and as most of them are here through the magic of technology with us, let's bring them back on screen so that we can thank them properly. Thank you all for your contribution to this forum today. All that remains now is to thank you, our audience, for your attendance and of course your questions and your enthusiasm and sharing your passion for solar cars. And of course, we have to acknowledge our key sponsors, the South Australian Tourism Commission and Bridgestone Corporation, who have made this forum here today possible. I would also like to thank our event management team and the technical team here in the secret studio who've made all this happen. The world is opening up, and as we have already started planning our next edition and seeing what that's going to look like, we are looking forward to the 2023 Bridgestone World Solar Challenge, and we sincerely hope you are too. Thank you for being with us here today.